Howdy doody. My name is Noah Norman. I'm going to try to make a series of instructional videos, not really tutorials, but explainers on the the idiosyncratic things about TouchDesigner, things that tripped me up when I got started, which was not that long ago. So I'm going to try to capture that feeling. If you're coming to TouchDesigner from another programming environment, like a C++ based environment, like Open Frameworks or Cinder, or if you're coming in even from another node-based environment like MaxMSP or VVVV or something like that, you may get hung up on some of the kind of paradigms in TouchDesigner that are specific to it. And hopefully these videos will help clear away that part of the experience as quickly as possible so that you can get down to being confused about the things you should be confused about, which are like math and 3D modeling and things like that. So the first one I want to start with is just looking at the op create dialog and why the ops are categorized the way they are. Really simply, there are 5 kind of basic types of ops, and then these comps, which are kind of mixtures of ops. The tops, excuse me, the tops are for making or modifying images. Things like the constant top creates a flat image of a certain size. The ramp creates a blended color across its area. Those are pretty easy to understand. An example of ones that modify might be like fit, which is just going to change the size of an image. And then maybe more complex ones that access things like memory might be like text or 3D, which is really a way to store a whole bunch of images, in this case 32, in memory, so that another op can go back in and access that memory. But the thing that's common across all of these, and I'm middle clicking on this, is that they contain image data, right? So they have a resolution, they have a bit depth, or a pixel format, which you can see here in the common tab here. You can modify the pixel format, and this is basically what you're looking at when you're talking about tops. With some exceptions, tops store images, and the images are in the kind of paradigm. It's pixels, right? They don't have to be image data, really. They can be data of any kind, but you're storing it through this metaphor of like a 2-dimensional matrix, which could also, in some exceptional cases, be 3D. So the text 3D is kind of an example of kind of breaking that rule. If you're coming from MaxMSP, you might be thinking like, okay, well, I see that the line is purple, and that probably means that I have an image on the line, right? And that makes sense. But you'll see that the image actually doesn't, the line doesn't change to indicate that I'm now, in this context, I'm actually looking at a 3D texture. So here we have an image. This is 2-dimensional, and it can change over time. But now that I've stuck a text 3D in the line, there is now a 3D texture in here, and nothing changed there. So maybe I should dig into that in a future video. But this is tops for you, and the kind of broader thing that you should be thinking about with tops is like images or image-like data. So that's mostly 2-dimensional data stored in a way that could be represented as colors. You can't always do it. If it's floating point, you might have negative values. They don't make sense as color. But for the most part, these are good for creating or modifying or even storing and recording image data. This is another one that there are examples. I should talk about this. I'm getting inspiration already. Subsurface ambient occlusion, or screen space ambient occlusion, I'm sorry, can rely on the output of a render top and actually not take the inputs like the other ones. So, but it still operates in kind of image world. Okay. Chops. Chops are, to me, probably the most confusing operator type, or at least they were when I first started. You can have a type of a chop. Now this is a single value in a channel. So no matter what I do here in my constant chop, if I don't change the single sample parameter here, I've just got a single value. And when I middle click on a constant chop, you'll see that I have this I represents a sample. I have one sample in here from start at 0, end at 0, right? In a single channel. I'm going to talk about channels in a second, but if I turn off single sample, now you can see that I have 600 of them. By default, I don't know why, these default to seconds. I don't think seconds should be the default for anything chop related because samples are more likely how you're going to be dealing with things. If I put this back to, if I put this back to 0, if I go from 0 to 0, you'll see I get back to 1 sample. But if I switch this to 1, now I have 2 samples, and the chop interface is actually going to change. It looks different now, and you can see that I have an x-axis, and the x-axis represents the number of samples in the chop. The floating point values in between aren't that meaningful unless I'm going to be able to interpolate between the two of them. And without jumping too far ahead, I'm just going to show you I can go chop to GAT, and I can see my 2 samples in here. They're both the value 4. Later on, I should talk about extending in chop world. It's a lot easier to understand in terms of tops. Like, you extend a top off the side. If I then translate the top, I can see the same value might extend if I set it to hold or if I set it to mirror or whatever. You can get the idea better. We'll talk about this later. But for now, just understand that a chop can contain, and let's just talk about a single channel for right now. A chop can contain 1 or more values. These values are 32-bit floating point values. And if I turn back to single sample, it's pretty easy to see I just have a single value in there. But if I turn off single sample and then I crank this up, whatever, now I have 10 values in there. They happen to all be the same value, which isn't that interesting. But let's get out another example, and we'll look at the pattern chop. And this is kind of like a constant chop, but it has a little bit more to look at. I'm going to copy my chop to dat so we can examine these values. Now you can see same idea. Now if I go in here and I change the length of this to be 10, just like the other one, you can see rather than 10 fours, I have 10 samples along the sine wave. Now the pattern is a really powerful chop, but it operates using the same basic principles of manipulating its length in terms of number of samples, and each one is a 32-bit floating point value. So if I look in here, my length here, number of samples, that could also be called number of samples. To call it length is actually kind of maybe a little bit confusing, but if I introspect on these, this one's actually 10 samples here, 0 to 10, and then this one is 0 to 9, and I have 10 samples there, and I have 11 here. So actually, I'm ending. You got to remember that these are not everything is 0 indexed in TouchDesigner, but samples are. Cool. Okay, so what else about chops? Well, we're going to start immediately bumping up against the stuff that is a little bit harder to understand, but you could also think of a chop in terms of its duration in time, assuming that you're working at 60 FPS, and that's actually set on a project level here. 10 samples is 1/6 of a second, so that's 0.17 seconds. If I were to change the FPS, this number would similarly change. You can see the sample rate is set at 60 samples per second, right? I can change that sample rate on a per chop basis here. If I change this to 120, this will actually be at 120 frames per second. Internally to the chop, it'll be 0.08 seconds. And you wouldn't do that too often unless you were dealing with, like, let's say, audio. You might monkey with the sample rate of a chop. It's probably best just to leave it at the project sample rate unless you have a specific good reason to do that. But this can be very confusing, the idea of a time window existing within a chop. It makes sense with audio. Like if I go audio device in here, this is, goodness gracious, okay. Immediately bumping up against stuff that's kind of hard to understand. I was just about to explain this, and then I was like, do I even understand this? Okay, so this is time sliced, and I guess my question would be, and I'm not entirely sure that I can answer it myself, but why? Okay, so my buffer length is 0.1 second at 44.1, which is why I have, I believe, 735 samples. I should probably do the math on that, and I'll just show you a kind of a dummy thing that I do sometimes. I use the calculator on my Mac or on my phone sometimes, but another way you can do this is you could say I have 44,100 samples and then divisor, whatever, is going to be 0.01, and then I would multiply these two, and already I know that that's not what that value is going to be. I don't know why I can't do math and talk at the same time, but if I multiply these, that should be 441, and instead it's 735 samples. Oh my goodness. You'd think I'd understand this stuff. Why is this 735 samples? Well, it is 1 frame's worth. That is why. Okay. So the buffer length might have nothing to do with this. Let's see what happens if I change the buffer length. I'm going to work this out in front of you. 0.5. No. Okay, so the buffer length has nothing to do with it. That's good to know. And instead, I know that I'm doing 1 second worth. So I should have 44,100 samples in a second. Oh, it's 1 frame. And 1 frame is 1/60th of a second. So if I divide 1 by 60, there we go. You know, guys, everything makes sense eventually if you just bang your head against it. I feel like I should be embarrassed about that. That's confusing stuff, and that's why we're doing this. Okay, so why does an audio device by default have 735 samples? The reason is because by default it is time sliced to 1 frame, and 1 frame at 44,100 samples per second, which if you don't know is normally how digital audio is represented because it's close to the upper range of human hearing, or the upper range of human hearing is 22,500 samples per second, or hertz, and the Nyquist's, basically you need 2 samples in order to be able to represent 1 cycle. So in order to be able to represent 22,000 hertz, you need 44,000 samples per second because you need an up and a down, and that would still sound like hell. But anyway, there you go. 735 samples is 1 frame's worth at 44,100 samples per second, where we're assuming that we're at 60 frames per second. So if I multiply 44,100 times 1 over 60, I get 735 samples. So that's a little confusing, isn't it? But this gives you a pretty clear indication of what time slicing is. Now, time slicing, I can't turn this off for an audio device, but I can for something like the pattern chop. I should be able to turn it off. Why can I not? I love it. I'm learning so much, you guys. Why can I not turn off the time slice? Well, let's do an LFO because I should be able to do that. So an LFO is going to generate sample changing over time, and I can't turn off the time slice. But if why not, you son of a bitch? There will be cursing in these videos too, just to warn you. Why can't I turn off time slicing on anything? So let me see if I put this into a math. Maybe I can turn off time slicing on a trail chop. I can probably do it on a trail chop. Let's do it on trail. No. Capture a time slice. Only the input cooks. Nope. I'm not going to edit this either. You guys are just going to watch me flounder. I don't know why I can't turn off time slicing on some of these, but it probably has something to do with my not entirely understanding what time slicing is about. But here I'm going to explain to you what I think time slicing is, and it's basically the chop stores the amount of data in the last time slice that cooked, or in the current time slice that's cooking. If you were to drop a frame or not compute a time slice for any reason, the next time slice might be longer. So the time slicing allows chops to maintain continuity without essentially dropping frames like you would in video. That's my understanding of time slicing. Please leave a comment if I'm wrong about that. Now, the trail chop lets you see what happens if you take a single sample instantaneously and smear it out over, in this case, 4 seconds. If I switch this to 60 samples, of course, this would be 1 second worth. And the LFO here is set to a frequency of 1 hertz. So you can see that I always have 1 full cycle, right? Which is 1 60 sample cycle in the frame at all times. Okay, so chops for the most part, again, I say for the most part because there are exceptions to this stuff that I want to get to, are for manipulating one or more numbers strictly in number world. And we'll get into some of the weird stuff about that later. I just want to point out, in case you're really coming from nowhere, you can have multiple channels in a chop, and you can see here if I do a chop to dat, we'll get to dats in a second, that I get a column per. That's because that's how I have this chop to dat set. But the channels are all pretty much the same thing. I can actually change the way they're displayed. Like all channels in the same graph here. That doesn't really help because they're different, or they're not all that different values. But there you go. Now they're set the same thing. You can see they're sitting on top of each other, right? But they're just occupying the same space. For convenience, if I want to do an operation on two of them, like I did here, I have two channels here, and then I use a math to divide them. But they're, for all intents and purposes, that's really no different than if I had a constant with one value in it, or I'm just making it constant because it's an easy way to generate. Oh, that's something I should talk about, is what can generate and what cannot. I'm not going to do that right now, but I hopefully will remember that I need to. It's a big point of confusion. Is like, oh, I have this value in Python and I need to get it into Choptown. Like, how do I do that? Well, you can use something in Python to set the value of a constant chop, but it's a little bit confusing. So I should talk about that in the future here. But if I multiply these two, it's the same thing. You can see as like dealing with channels that are in the same chop. There's nothing special about that. It's just a convenience thing. Okay, so that's chops. Great. SOPs. SOPs are a whole different context from chops from tops. Tops are dealing with matrices again of numerical data. Chops are for dealing a certain kind of like, in a certain sense, with arrays of numerical data. And then in tops, you can change the storage format. Chops, you cannot. They're always 32-bit floating point. In SOP world, you can have any number of things in SOP world, including you can kind of make up your own things to store, kind of like you can in chops. But again, I'm middle clicking on this thing, and you can see just out of the gate, if I make a box, that I have 24 points. And I don't want to get into 3D stuff too quick, but the points are part of a vertex. The vertex stores the point. Vertices belong to polygons, which themselves are primitives. And if I wanted to look at this another way, again, DATs are a great way. SOP2, CHOP2, DAT, whatever it is, are a great way to look at this stuff. So here are my points, right? If I go to the vertices, you can see that the vertices have the UV information on them. I don't want to get into 3D stuff too much, but and then there are the primitives, and the primitives contain the vertices. And this should be nothing at the moment. But, okay, so I have this box, and the box is a collection of points in space. It's probably the simplest way to think about it. If I hit A, and then I right-click, and I go to Display Options, and show my points here. I can even show the numbers on them. Let me turn off the points so you can actually read these. You can see that there are something like, what do we got? 23 points, and that's why some of them, they're not unique at the moment. Or they are unique at the moment, which is why it's hard to read, but there are 2 points, or 3 points sitting on top of each other right here. But I have this collection of points in space, and by in space I mean they have an X, Y, Z coordinate, and they even have normals right out of the gate. So in SOP world, this is what's actually in the SOP. This is a visual representation of the SOP. This box, there's kind of a camera in this view. It happens to be a perspective camera. I can zoom it and I can tumble it and stuff like that. I'm actually tumbling the SOP itself. I can switch to orthographic. You can see I'm getting some Z fighting there, but here's the ortho view. But I really don't have a lot of control over this rendering per se. So don't get confused and think that there's actually a box in this SOP. There isn't. There's a bunch of data in this SOP that I can use later on to make an image that looks like a box. That sounds like a kind of pedantic kind of thing, but it's kind of important to think about that. Like, SOPs are actually tables of data that you can use in order to make a rendering or other things. You can use them to control other things. You can dump them into Chop World and use them to make sounds, whatever. So think about SOPs as, again, like groups of numbers, just like chops, just like tops, just like all programming. It's all numbers underneath, right? So in here we have a bunch of numbers. I could create new attributes on these, let's say on the vertices. If I go into the modify the vertices, I can go in and I can say dogs, and I think it's me input point. That's not the value. I don't even know these things off the top of my head. So let's get into something really quick. I don't want to go too much into actual programming or like too much details like that. But if I go in maybe not num points. No, I'd have to access the points. Is it input vertex? I'm on the vertex, that's why. Duh. All right, vertex. So now I have this thing. I have a custom attribute on here. You don't like that, huh? What? Float argument must be a string or number, not TD vertex. Oh, is there a value? You guys, I shouldn't even be doing this stuff in front of you. To be fully honest, I can't cast that as an int. Can I do that? No, and I can't store a string. Well, I need to access the number out of the vertex. I just want to do this so you can see what this looks like. Here we go. Input vertex, the vertex being evaluated, and then access the point, and then from the point, I thought I could get a number out of this thing. Maybe not. All right, whatever. So anyway, I made this dogs attribute, and you can see that this thing now has a new vertex attribute, and it's dogs, and it's a single value. If I switch this to vec3, I don't want to go too far into it. You can see that I now have an array of 3 dogs values, this, and this, that I can dump into this. And then if I'm not a moron and I can script these in a way that I can get a different value in for every vertex, if I go then to another sop2dat, you now see that I have, how do I introspect this thing? Oh, it's on the vertex, duh, there we go. I now have a dogs column on my vertices because I used a vertex to add this attribute. So again, I'm just really, this is actually what's in here. The DAT always kind of tells the truth in a certain sense, because you're not looking at a visual representation. And again, don't think that like in a chop that the line is actually in there. The line's not in there. But I can go from Choptown if I say like I have a pattern. And again, a chop is just kind of a way to store numbers. I can go from this chop to SOP, and it's going to complain because I don't have channels in here. But if I change this thing, what do you want? You want TX, TY, TZ. I'm going to change this to TX, and actually I'm just going to change this to TXY, YZ. Now I have this shape in here that happens to be a diagonal line. I don't think I can change these relative to each other, so really what I should do, and I just want you to see that I can do this, not me personally, but that you can do this. I'm going to actually just say TX, and then I don't actually need a Z in order to do this, so I'm just going to do 2 to save a little bit of time. TXTY, and I'm going to make this a, I don't know, a ramp, and then boom, and actually I'm going to make this the X. We'll see why in a second. And this is a TY. It's not important that you follow why I'm doing this so much as you can see. Oh, look at that. Okay, so we have a collection of points in space. How many points? It's 1,000 points. Why? Because this is 1,000 samples. And we just took these 1,000 samples and turned them into a SOP representation. But what's actually in here, am I going to just hammer this home one more time? Don't think about it as really as a 3D object. It's just a collection of points in space. And, you know, not to belabor the point too much, but if I do this, and then I do chop2dat, boom, these are going to look very similar. This column and this column are going to be very similar. Why does my X look different here than it does here? They're starting in different places. One goes from 0 to 1. One goes from 0. Why does my P0 start at -1? Oh, right. I need this to start 0. Right. Okay, so when you are translating a chop to a SOP, you have a degree of control over how that gets interpreted into 3D space. There's kind of a scaling or like a transform that you can do in here, which is a little bit confusing. So I don't want to get too far into the weeds on that, but these are essentially representations of the same thing. Okay, so staying in Soptown, sops are collections of numbers that are generally meant to be interpreted as representing something in two-dimensional or three-dimensional space, but are really meant to be operated on as surfaces. That's the name, surface operators or objects. There are weird sops in here that just modify things or just create like weirdo things, like a metaball, for example, isn't really something you can render. And if I connect it to a null, it's not like the line looks different. It's still the same blue, but it happens to be a metaball. So we can come back to some of that oddball stuff, but just know, for generally speaking, that sops are collections of numbers that can be used to represent objects that in some cases can be rendered. So you can think about them as kind of like object world or 3D world, right? Okay. Materials. These are probably the simplest category to talk about in a certain sense. Maybe DATs are, but materials are really only used for 3D rendering. So a constant isn't really anything by itself. There's not a lot to talk about here unless I use it in the context of rendering. So if that doesn't mean anything to you right now, don't worry about it. There's only a couple special materials. There's an in, there's a null. We should all know what a null does at this point, but maybe I could talk about that in a future video. There's a switch, which is like a logic. You can actually like connect multiple mats and you can switch between them. It's a little, honestly, weird, just because there's also a select and operates under the same. You can script a select, but anyway, I should talk about selects at some point too because they're weird, and I should talk about scripts because they're switches because they're kind of singular. Okay, so that's mats. We can come back to 3D stuff later. I'm not really the best guy to talk to that stuff. And so DATs, this is kind of our last basic op category. What's the deal with DATs? Well, DATs store, very simply, can store text. Text. Well, we'll leave it as text. If I connect this to a null, you'll see that I can have unstructured text in a way. So this is just kind of a plain text thing, right? It's 5 bytes worth of text. It's assuming that it's Python. I can actually now, this is a new thing, but I can change the language that's assumed in here. So if I switch this to GLSL and then I edit this in an external editor, it will know that I'm in GLSL. That's very convenient. There's nothing special about the text. It's actually the file extension that this gets written with. There are tables in DAT world. This is just more structured. I can bring things in from outside, like a CSV or something, and go in for some data out here, and then convert it to a table. It doesn't have anything right now, but it'll turn it into a table. DATs are pretty straightforward. They're mostly for handling text, and you'll do all your scripting in here, and you'll store all your stuff in tables in here. And sometimes the stuff that's kind of special about DATs, the thing that you need to know about DATs, maybe that might trip you up early on, is that DATs are also a context from which code gets executed. You can't execute code in the top. You can't execute code in the chop. You can't really write code in any of these. I mean, you could, but it'd be like a kind of crazy hack. You'd be doing it to be elite hacker. But in DATs, you actually write the code that can be executed. So for example, the execute DAT, I can write a little bit of code that every time TouchDesigner starts, I can put in my thing here, and I can say, debug, good morning. That's dumb. I didn't say hello world though. So anyway, that, this is a context in which you can actually fire off code. So maybe a better place to do this would be here, and I'm going to say debug, good morning. I'll save, and then I'll come out here, and then if I show the text port by hitting Alt-T, here's my text port, and I highlight this and I hit Control-R, good morning. So from DATs is kind of a privileged position of a place that you can actually execute your code, whether it's Python or TScript or GLSL or C++ or whatever it is. Executing means different things in those contexts, but this is where code goes. Last category to wrap this thing up are comps. Comps are not that the other nodes aren't actually made out of other nodes, but comps are actually nodes made out of other nodes. So if I go to drop a time and I go in here, you can see that there are a bunch of other nodes in here. These kind of all have special, very idiosyncratic TouchDesigner functions. The only ones that are organized, if you're looking through the Op Create dialog, the only ones that are organized by category. These panels are all fairly self-explanatory as like UI elements, right? So the list is like a drop-down list you might think of, right? Field is like a text field. If I go in here and howdy, and then if these were part of like another interface, I could build up, for example, a program like TouchDesigner out of these. It is made out of these UI elements and some other ones that live in the palette. These 3D object ones are all very special in their own kind of way, like a geometry. I don't want to go into these too much, but a geometry is a comp that can store, create a context for you to render an image out of. So with the geometry and a camera, I can then, so these are both kind of, you can see they're comps, right? And this is a SOP. I get a SOP to the geometry, and I use a camera to tell it where to look, and then a render. I'm coming back into Top World to make an image, and there's the box that I made. It's all black because it doesn't have any lights on it, but you get the idea, right? Okay, so comps aren't easy to generalize about, except that they're kind of the highest level operators in the palette, and on the palette in the Op Create. They have very complex functions that are actually made out of a lot of other things, and almost every one of them is kind of special in the world of TouchDesigner. They all do things that have their own kind of set of rules around them. Okay, so I hope that was helpful. I know I moved quick. I'm always going to move quick with these. Please leave comments. Let me know what kind of things are tripping you up. And feel free to ask me for clarification, and definitely call me out on things that I got wrong. I mean, this was elucidating to me that just like, I've always said chops are a big blind spot for me. And I'm going to try to reinforce some good habits. And as we together work out a common style for TouchDesigner, I'm going to try to reinforce that. We're all learning from Matthew and from Keith and from the guys at Derivative how best to use the program. But I'm starting to push to standardize in a certain way some of the stylistic things that we're doing so that we can read each other's code better, so that we can use each other's code more easily, and so that we can move faster without stumbling over one another's practices. So please leave a comment. Let me know what I got wrong. Let me know what you want to hear about. Thank you for watching episode 1. Holla at your boy. Goodbye.